Hello, today I want to go through a question involving probability. This is an example of independent events and using probability trees to solve problems using them. So if we have a look at the question down the left hand side, a fair spinner has 12 equal sections, 3 red, 5 blue and 4 green. It is spun twice. I need to model that situation, and there's a really useful way of doing that is using a probability tree. So I'm going to have 3 branches on my probability tree to represent the 3 different options. I can either get a red, a blue or a green section when I spin my spinner. So I'm going to write red up there just because that's the order I'm giving it, and I know that 3 of the sections are red and there are 12 sections in total, so therefore I know the probability of getting a red is 3 out of 12. Likewise, if I do the same with the blue, I know that 5 of them are blue out of 12 again, so that's 5 out of 12, the probability of getting that blue, and then there is a probability of 4 out of 12 of getting the green. But after that first spin, regardless of what happens and what colour I land on, I have a second spin, and regardless of which colour I got to start with, I can still get a red, blue or a green, and the probabilities remain the same. So I need another branch off of my probability tree, or 3 branches, to represent the second spin after I've got a red. And after I've got a red, I can still get red, which would have the same probability. I can still get blue, which would have the same probability. Because I've not changed my spinner, there's still 12 equal parts, and 5 of them are blue and 3 of them are red, and actually 4 of them are green. So those probabilities stay exactly the same for the second spin. And that was only me modelling what happens on the second spin, given that I got a red on my first spin. So I also need to model that for if I got a blue on my first spin, but you'll see it's exactly the same look: red, blue, green, 3 out of 12, 5 out of 12, 4 out of 12. And also, those probabilities are exactly the same if I'd have got a green on first spin as well. So I can represent all the different possible routes using this tree diagram. It's worth thinking about our route through each set of branches on the tree and thinking about what I end up with. So I could get red and then red. I could have got a red and then a blue. I could have got a red and then a green. I could have got a blue and then a red, could have got a blue, then a blue, then a green, green then red, green then blue, green then green. And all of those possible outcomes can occur. But now I'm going to go back and read the question, because it's actually asking me, what is the probability of getting the same colour twice? Well, if we look at our outcomes, that only occurs 3 times. Look, I can get red and red, I can get blue and blue, or I can get green and green. So actually, to answer this question, I only need to figure out those probabilities. Now, as I work through my probability tree, if you look at that red then red section, the probability of getting the first red is 3 out of 12. The probability of getting the second red, because these are independent events, and we might look at conditional probability a little bit later on, because these are independent, the probabilities are exactly the same, so it's 3 12s times 3 12ths. That gives me 9 over 144. For the blue, then the blue, it's 5 12ths multiplied by 5 12ths, because they're the 2 probabilities, independent probabilities of getting blues. That's 25 over 144. And for the green and the green, it's 4 12ths times 4 12ths, which is 16 over 144. All 3 of those outcomes satisfy what the question's asking. They give me the same colour twice. So I can have 16 out of 144, or I can have 25 out of 144, or I could go the way that had a probability of 9 out of 144. So all of those different probabilities satisfy the parameters of the question. So I can add all of those together and I get a total answer of 50 out of 144. I need to simplify that because I'm a GCSE student and I want to get all the marks. So I can see there's a common factor of 2, and if I divide top and bottom by 2, I get 25 over 72. I don't think there are any more common factors, so I'm done.